What is phototransduction? Phototransduction is the phenomena. It is also called visual visual transduction. I only discuss this phenomena by the rhodopsin and the rod cell. This is the rod cell, but this phenomena is same for the cone cell and the by the cone pigment. But I discuss only for the rhodopsin and the cone cell. Same thing is here. Okay. Phototransduction or visual transduction as the phenomena through which this is the very chemical reactions, this transduction mechanism through which light energy is converted into the action potential. What is phototransduction? Phototransduction or visual transduction is the process by which light energy is converted into the receptor potential and the receptor cell. This is the receptor cell in which light energy fall on the rhodopsin. Light energy fall on the rhodopsin and the visual receptor. This is the receptor cell. This is the rod cell. Converted into receptor potential. Okay. But here, this is the only cell in the body. This is the only stopped cell. This is the stopped cell, which is different from all body cells. This is the rod cell. This is the rod cell. Here, cone cell. Okay. In the body, as we know that all the cell, like muscle cell, all the muscle cell, all the neuron cell, these are the excitable cell which undergo excitation. As we know that from my previous class, the action potential, I have already discussed the action potential in the previous class. Suppose this is the neuron, this is the axon cell body, and these are the dendrite. When I zoom this only small dendrite area, okay. Look at this one concept. This is a very strange concept. This is very good concept. This is a neuron ending when I zoom this area. Okay. During resting state, during unstimulated state, this neuron is inside negative charge and outside is positive charge. This state is called the polarized state. Suppose this is the neuron cell. This is not the rod cell. This is the neuron cell. Okay. When I touch this area, then here the sodium, because this area is positive, because here present sodium potassium pump, which transfer 3 sodium outside and 2 potassium inside, and potassium and sodium 1 charge, positive charge. Okay, the net result is negative because this is the 3 sodium and the net result is positive. Okay, so the net result is negative. This is called the polarized state. This is the resting state. This is the unstimulated state. Okay, this is the polarized state. When I touch this area, the sodium go inward by a specific channel which is called sodium voltage regulated channel, and potassium go outward, which is by the potassium voltage regulated channel. Here the polarization is disturbed. Here negative side, positive side. When sodium go inward, current is inward. When potassium go outward, current is outward. So the current go in the forward direction in the palm up here. Okay. So point to be noted. And the neuron cell and the all body cell, except this one, except this one cell, except this baby cell, this cell, this all cell, all this cell, all body other cell have different phenomena against to this one. Okay. So there the is the background concept. Actual concept is this one. There the action potential is go forward and the during the depolarization, because their polarization is disturbed. But and the rod cell or cone cell, the potential is go, the receptor potential is go during the hyperpolarization. Why it is go? Why the action potential go during hyperpolarization? I will prove this one here. Okay, I will prove this one here that the rod cell is excited during the hyperpolarization, but the all the cell excited during the depolarization. Okay. Suppose this is the neuron cell. Neuron cell is a minus 70 millivolt plus 70 millivolt. Okay. The muscle cell is minus 90 millivolt plus 90 millivolt. Okay. This is for the resting membrane potential in the muscle cell, and this is in the neuron cell. Okay. But and the rod cell, the polarization state is only minus 40. We release millivolt. Okay. So what is mean by this concept? Here the sodium go outward, potassium go inward by this channel. This is the unstimulated state, but during stimulation other channel is open. Okay, here the same but different phenomena. Look at this one diagram. There present sodium potassium pump which transfer three sodium outside to potassium inside, but there present another channel which is called sodium calcium combined channel. This is the channel for the combined. Only this channel transfer sodium. Here the sodium go outward, potassium go inward. Okay, look at this. This is the normal state. Okay, but here the net result is the positive charge. Okay, positive charge. There the sodium go outward, potassium go inward. There the another channel which transfer sodium go inward, and potassium is also go calcium is also go inward. This is the unstimulated state. This is the state, suppose this is the unstimulated state where light is not fall on the rod of cell. So during the unstimulated resting state, this is the inside is positive, outside is negative. But in the neuron, like this one, the neuron or muscle cell, this is the resting state, inside is negative, here inside is positive. Opposite phenomena. Okay, but this is the opposite. This is the opposite phenomena, opposite cell. But suppose when light fall on the rhodopsin, this is the rhodopsin molecule. This is the rhodopsin molecule on which light is fall down. Light beta rhodopsin convert to the LEMO beta. Finally, I only consider this area, this point here. At final stage, the meta rhodopsin 2 is broken down. This is the rhodopsin is broken down into all trans retinol, and the opsin or scotopsin more clearly. Okay, when light fall, they produce. This is the opposite for the other cell. Okay, so they produce hyperpolarization. When they produce hyperpolarization, the inside become negative, outside become positive, so the potential is go in the forward direction. How this occur? When light fall, okay, another point in the resting state, this is an enzyme, guanylase cyclase is the enzyme which convert GTP to the cyclic GMP. Okay, GTP convert to the cyclic guanosine monophosphate. Guanosine monophosphate attached to this channel and open this channel, and sodium go inward, potassium calcium go inward. This is the resting state. Suppose this is the resting state. Okay, so positive and negative. But stop at this point. But when light fall, this molecule become destroy and no longer attached here and close this channel. How it close this channel? How it break down this molecule? Okay, the opsin stimulate a protein which is called transduction. What is this? This one. This is the very big ant. Where is ant? Where is ant go? This one. Or ant is diode. Ant. Okay, when light fall on rhodopsin, convert opsin activate transduction protein. Transduction protein activate another enzyme. This is the enzyme which work opposite to this one. This is the guanylase enzyme which work in resting state. This is the cyclic guanosine monophosphatase, simply CGMP. This is the enzyme which break down the CGMP. This is the enzyme which produce CGMP. When this enzyme activates CGMP, when activate cyclic guanosine monophosphate or simple monophosphatase or simply PDE phosphatase, phosphodiesterase. Okay, same concept. CGMP is activate. CGMP come on and destroy this one. When this one is destroyed, the concentration of here the concentration of CGMP is decreased, and this channel open closed. This channel closed because CGMP is lost. When the CGMP is lost, no CGMP is attached here, and channel closed. Okay, so no sodium come, no calcium come, but here the sodium potassium ATPase is present, which work all the time during resting state, during stimulated state. This continue its own work. It push 2 potassium and 3 sodium outside. So the net result is negative. Net result is negative on side. Okay, the net result is negative, slight polarization, slight hyperpolarization, hyper. Okay, so the answer negative because channel closed. Okay, so here the hyperpolarization is produced. Okay, so this is called inhibitory post synaptic potential, IPSP. This is the inhibitory, small inhibitory. So there the excitation is produced, excitatory post synaptic potential. There inhibitory because negativity is produced. This small negativity go downward to this area. Okay, so there very small amount of glutamate is released, very small. When the inhibitory potential is reached here, no calcium or very small amount of calcium go inward. When the calcium go inward, when the calcium go inward, it release large amount of glutamate here in the neuron because action there the excited potential. Okay, but here the inhibitory, so least amount of glutamate is released. These are the physical filled with glutamate. Okay, the main purpose of the hyperpolarization in this rod cell is only have the one benefit. So they release small number of the glutamate. What is the benefit of the hyperpolarization? Small very least amount of glutamate is released because nature produce their different types of receptor. This receptor is only stimulated. This glutamate is attached here and stimulate this cell, and their glutamate is released and stimulate this receptor, this cell, and the action potential is go to the brain. But in the neuron cell and other cell, there the receptor there the receptor is produced by the nature for the large amount of the neurotransmitter, but here the receptor work only at very low amount of the neurotransmitter. Okay, so nature produce this phenomenon hyperpolarization in order to release least amount of the very least amount of glutamate. If large amount of glutamate is released here during some abnormality, then their nature produce horizontal cell. I will discuss this one later. Okay, so least number of glutamate stimulate this area. Okay, when it stimulate this area, we release amount of the excitatory. This one is suppose when I zoom only this small area, when I zoom here. Okay, so when glutamate, this is the receptor for glutamate. When this glutamate is attached here, there sodium go and the resting state. This is the negative inside, positive outside. This is the resting state. This is the cell like other body cell, which is different from this one. So the excitatory post synaptic potential is produced. This is also called the local potential or greater potential. It is not propagated, but it only produce. It help only in the. It is my previous class concept. The local potential is only help in the production of action potential. Action potential is produced here. So excitatory potential, post synaptic potential, or local potential, or this is called the local potential because it is local. It has a non-local. Non-local is action potential. This is the local. Okay. Here it inhibitory post synaptic potential, in excitatory post synaptic potential. Okay. So here release somewhat large number of glutamate is released here. Large number of glutamate when the potential is reached here, like this phenomena. There is large number of glutamate is released. When large number of glutamate is released, this is the cell like other body cell. So this cell is activated. This cell is activated only during the large glutamate, large neurotransmitter. So it produces action potential. The real action potential like this one. The action potential is produced, and this is the dendrite. This is the cell body here. This is the axon. This is the uptake narrow. Okay, so this is the uptake narrow, and action potential is reached to here. Okay, up or spin, quick revision. Light pole before light GTP convert to CGMP. CGMP is attached here. When attached, it open the channel and go sodium calcium go inward. So this positive side and this negative side. But when light fall, this is the reverse process. When light fall, upstream produce, all transretinal produce, stimulate transduction, stimulate this one, it break down this one and close this channel. Inhibitory stimulus is produced, least amount of glutamate is released, and here is attached large number of glutamate is released, and action potential is produced. Okay, so this is the reverse process. When light stop here, it does not produce opsin. The opsin and this one after action quickly combine together and produce opsin, and all transretinal all transretinal converted into the 11 cisretinal combined together make rhodopsin again. Okay, but after action this again make the rhodopsin very quickly. Okay, when light not fall, does not activate, does not break down, channel open, remain open, and the negative positive side, and no release glutamate. Okay, but what is the function here? At present, their nature produce another cell. It's called horizontal cell. This one, horizontal cell, connect the rod and cone cell with each other, and rod with rod, cone with cone, rod with cone. Okay, the function of this cell is that just like the controller. This is the controller part. As you know that this cell release very small amount of glutamate, and during small amount of glutamate this part is stimulated. When large number of glutamate is released here during some abnormality, everything in the world is non-real. So the rod cell is also non-real. It may produce large number of glutamate. When large number of glutamate is produced here, so this may lead no potential, but nature produce horizontal cell. Horizontal cell take this glutamate, and when horizontal cell stimulate, this horizontal cell again produce GABA. What is mean by GABA? Gamma aminobutyric acid. Gamma aminobutyric acid act on the rod cell or cone cell and decrease the release of the glutamate further. Okay, so this is the relay station. Here is the amacrine cell. This is the horizontal cell. This is the amacrine cell. Okay, amacrine cell also as a relay station, but have its own function, which I do not have a clear concept for this amacrine cell. Okay, I do not explain this one because I have no clear concept for the amacrine cell. Okay, so these are all about the phototransduction. Okay, so this is a very large topic. This is a very long topic.